Alright, so this is just a follow on from my first video where I talked about the sine, cosine and tangent ratios. So remember, they're ratios, as we can see here on the right hand side, between the sides of a right angle triangle, and only a right angle triangle. So we just remember, so sine A is the opposite side over the hypotenuse, so that's the far away one over the long one. So then we've got cosine of A is the adjacent over the hypotenuse, and the tangent of A is the opposite over the adjacent. So we need to remember that. It's the opposite one to the angle you're looking at. And the way we remember it is SOHCAHTOA. Okay, so SOHCAHTOA is how you remember it. And it's also, of course, in the formula book, I think page 16, but don't quote me on that. So the angle A is marked on the diagram below. I'm going to go through some exam questions now. So we'll start off with the lowest level, so junior cert ordinary level. So you're told the angle A is marked in the diagram below. Write sine A as a fraction. So in every question, from here all the way to Leaving Cert higher level, always label your side. So A is there, so this is the opposite, this is the adjacent, this is the hypotenuse. We know that sine is opposite over hypotenuse, so it's 5 over 10 or a half here, okay? And it says, hence find the size of angle A. So you remember from part 1, if you have sine A equals a half, you will do A equals sine minus 1, or sine inverse, so that's shift sine of a half, and you will get 0.5, you will get 30. Okay, so 30 degrees is the size of angle A. Okay, so it's just straight calculator work there. Okay, here's another question here using the same method. So this is something to do with a school and the height of a school. So this is from 2023 paper. So Sean's value, so obviously this isn't the first part of the question, his value for the angle of elevation was 57 degrees. His clinometer, so that's the thing from his eye level, was at a height of 1.42 meters, and he was standing 4 meters away from the school wall, and he got this diagram. So you see, big diagram here. So use the right angle triangle to write tan 57. So we know that tan is opposite over adjacent. So let's take a look at, here's our angle. We've got our opposite and we've got our adjacent. So it says in terms of x, that means x is going to be a part of our answer. So we have the opposite is x and our adjacent is 4. So the answer is simply x over 4. And then it says, use your calculator to find the value of tan 57. So that's literally just type it into your calculator, just make sure it's in degrees mode, make sure there's a little d, not a little lower on the top, it's degrees, not radians. And it says the 2 decimal places, so when you type that in, you'll get 1.54. Okay, so nice easy calculator work there. And then using his measurements, Sean works out that x is roughly 6.16 meters. So you don't even have to work that out. I suppose if you did have to work this out, you would do 1.54 equals x over 4, and then you would just multiply it by 4. So that's how you would have ended up with 6.16 if you were asked to do that. But use this value to find the total height of the school. So if x is up here, we see 6.16, and then you're just literally adding 1.42. So 6.16 plus 1.42 is going to give us 7.58 meters. Okay, so that's not so much trigonometry, but if you were asked to find x, that's how you would have done it. You'd have multiplied each side by 4. Okay, so that's ordinary level. At junior cert, it's usually just reading the diagram or writing down the numbers. Okay, so let's move on to another junior cert one. So Michael is designing the roof of a house. The width of the roof is 6.1 meters, and it'll be the shape of a right angle triangle of height h, where h, e, or. So that just means it's a real number. Okay, so it could be a decimal or a fraction. Okay, here's one possible design, not to scale. Calculate the slant height. Okay, so we see a right angle triangle, and you have 2 sides. So if you have a right angle triangle and you have 2 sides, that means you are definitely going to be looking at Pythagoras. Okay, because there's nothing said about an angle here. So With two sides, you're going to be using Pythagoras. So if you remember Pythagoras' theorem is c squared equals a squared plus b squared. So the right angle triangle, the length of the hypotenuse squared is equal to the length of the two sides squared. So in practice, that means c equals the square root of a squared plus b squared. So in this case, c will be equal to the square root of 6.1 squared plus 2.84 squared. And what we get then as our answer for that is 6.73 meters, 2 decimal places. So usually these trigonometry questions start off with a Pythagoras part. Okay, so next part then, a different design for the roof, and this time you are given two sides and an angle. So when you're given two sides and an angle, or an angle and a side, you are looking for SOHCAHTOA. So that's what we're going to be looking at here. So let's label our sides. Here's our angle, here's our opposite, here's our adjacent. So that means we're going to be using tan. So tan theta equals 3.12 over 6.1. So when we have the tan, but we don't have the angle, we do theta equals tan minus 1, 3.12 over 6.1. And that will give us to the nearest degree, so you just have to round it, it will give us 27 degrees. So fairly straightforward how to work that out. There's a Pythagoras question and then there's a SOHCAHTOA question. I think the third part of that question involved similar triangles, but we're not going into that now. So let's just keep going on down to another few. So here's a full question. It's got a few different parts, but it's mainly trigonometry. So you can see the first part's very easy. 7.5 kilometers is how many meters? So obviously there's 1,000 meters in a kilometer, so it's 7,500 meters. But that's useful for the second part of the question. As we can see, a plane took off from an airport, left the ground at point T. After a few minutes, it was 7.5 kilometers from T. So let's just put down what we learned in the first part, 7,500 meters. It was 200 meters, so we're keeping the units the same. Above level ground, as shown in the diagram, to scale, of course. So use trigonometry to work out the size of the angle E. So this is just going to be another simple trigonometry question. We've got a triangle. Let's label our point. Here's the opposite and here's the hypotenuse. So you need to find the size of the angle E. So we've got opposite hypotenuse, that means sine E equals 200 over 7,500. Now you make sure the units are the same. So that means E equals sine inverse 200 over 7,500. And that will give you 1.5 degrees. So it's only a very small trajectory upwards. So continuing on, we now get to do a bit of time work. Okay, so 20 minutes is a fraction of an hour. Again, very easy. One was 20 minutes out of 60 in an hour. So that will simplify down to 1/3. So it's 1/3 of an hour. Again, that's going to be useful in the next part of the question. So during part of this flight, it travelled 598 kilometres in 2 hours and 20 minutes. We got the average speed of the plane in kilometres an hour. Okay, so remember distance, speed and time. If we did it as a triangle, so speed is distance divided by time. So we want it in kilometers per hour. So we want kilometers on the top, so that's grand, 598 divided by hours. Now 2 hours 20 minutes, we can't put down 2.2, it's going to be 2 1/3 hours, or 7 over 3 hours, or 2.3333 recurring hours. So you want to do 598 divided by 2 1/3, whatever way you want to put. Probably easiest is just to put in the 2.33333. Okay, so you do distance divided by time, and that will give you an answer to 1 decimal place of 256.3 kilometers per hour. So make sure you put in your units as well. So just make sure that's the thing that'll catch people out. It's not 2.20, it's 2.333. Okay, and to finish off this question, each of the points represent an airport. The plane travelled 598 kilometres from airport A to B, and then it went on to C. Now, that's actually not particularly relevant, this bit here, but what is relevant is we want the distance AC. So, as we can see straight away, it's going to be split in two parts. So, let's work out, let's see, we'll just call this part D. Okay, we want to work out all of it. So of course, try it yourself first before I do it, but let's see, we've got A, D, and B. We've got 280 and 598. Okay, so two sides, and we're missing a side. We're going to use Pythagoras. Now we have the long side, C, A, and B. So what we'll do is we'll do the square root of C squared, so that's 598 squared, then minus 280 squared. Okay, so we're using a minus here because we have the long side, and that gives us 528.4 kilometers. Yeah, this is all in kilometers. Okay, but then we also need to get DC. So let's draw the triangle the other way. Always draw the triangle you're working with. So B, D, and C. We've got a right angle here. So you've got 280 and you've got 35 degrees. So that means we're going to have to look at our opposite and we need our adjacent. So we have got tan 35 equals 280 over, we'll just call it A. Okay, and so remember when the letter's on the bottom, we're going to have to divide. So A equals 280 over tan 35. Okay, and that's going to give you 399.9. Okay, so all we've got to do now, we've got the two lengths, okay, and all we have to do is add them then. So plus 528.4, and you have, so we'll just plus the two of them, and we have our final answer of 928.28. Okay, or 928.3, but it says in the nearest kilometre, so just 928 kilometres is fine. Okay, so a bit of trigonometry, a bit of mixed stuff here in that question. I'll zoom out a bit, it might be a bit small on your screens. You can see that there's lots of stuff going on there. Right, next question then. Two vertical buildings, not to scale. She stands on top of building A, so this is where she is. Mary is standing on the top of that, 220 metres above ground. She wants to work out the distances marked Y and Z in the diagram. So from the top of building A to the bottom of building B, that's this one, and the height of building B, that's that one. Okay, so it's a bit of a complicated diagram, but just get your triangles from it. You've got 35 and 20 degrees there. Okay, so we just follow what the diagram says. Okay, work out the size of angle C for a start. Well, you don't have to use trigonometry here, so we know that a right angle triangle is 90, or right angle is 90 and 35, so we do 180 minus 90 minus 35, and that's what we have left. And we get 55 degrees. Okay, so C is 55 degrees. So that'll be important now in working out things. I presume it will be anyway. Right, so I know things will be kind of smaller on your screen at the minute, but we just need to keep the diagram there. So Mary works out the horizontal distance is 154 metres. So use the theorem of Pythagoras. So again, we're using Pythagoras to work out the distance marked Y. Okay, we just need Y. Let's draw a triangle for it, as always. So we've got 220 over here, 154 here. Okay, and now we can use a Pythagoras for Y. So we've got the two short sides. So that means we're going to do the square root of each of them. So 220 squared plus 154 squared. Okay, so we put those two together, and that will give us to the nearest metre. That gives us 269 metres to the nearest metre. Okay, so you can write down your amount and then round it. But when you've got the two short sides, remember it's C, A and B. So C squared equals A squared plus B squared. And then we've just square rooted both of them. So Y equals 269 metres. And finally, use trigonometry to work out the value of Z, the height of building B. Okay, so we're going to have to do a couple of things. So we know that part of Z down here is obviously 220 metres. So we don't need to worry about that. What we need to worry about is this top bit up here. So let's draw that triangle. We've got 20 degrees in there. Got 154 as our length. And we need to find, we'll just call it X. Is X okay to use? Yeah. Okay, we're going to call it X. Okay, so what we have to do is we need to label our sides. So we've got our opposite, we've got our adjacent. Why is that popping up? And so we're going to be using tan. So tan 20 equals X over 154. And if you remember back, we are going to times by 154. So we'll times by 154, times by 154. Both sides, you'll get 154 tan 20 equals X. And that will work out when you put in your calculators as around 56. Okay, and it says the nearest metre, so that's why I just rounded it. But don't forget that's not all of it. Don't forget the 220 as well. So the total of Z is 276 metres is the height of the building Z. Okay, so don't forget to finish it off, or you'll lose a few marks there. All right, so that's some Junior Cert 1 sorted. Now let's move on to some Leaving Cert 1s as well. So here's a Leaving Cert, and generally trigonometry comes up in paper 2 in all of the Leaving Cert 1s. So let's look at this. Fish shop has a vertical sign outside its front door. It's represented by FH, with FH equals 3 metres. So we've got a triangle here, nice and easy. Cable is tied at the top of the sign F and secured to the point G, and it's 1.4 metres. Again, look at the way this is starting. Use the theorem of Pythagoras to solve the length of the cable. So remember, c squared equals a squared plus b squared, and so we'll just get the square root of that. So GF is what we're looking for, and it's simply the square root of 1.4 squared plus 3 squared. And that's all we actually have to do in that. And it is going to be 3.3 metres. Okay, 3.3 metres there. Okay, square. Yeah, that's simple. 3.3 metres. It comes up in your calculator as root 274 over 5, and that just rounds to 3.3. Okay, show that the size of the angle, so they're actually giving you the size of the angle is 65 degrees. So the way you show it is you do out your triangle, okay, and we've got 1.4 and 3. The other side doesn't really matter. So you have to show it, we'll just call it A, just because it's FGH, so it's F down to G over to H, so it's that angle, it's the one with the G on it. So what we need to do, very simply, what have we got? We've got an opposite and we've got an adjacent. You see this is the same thing every time. So we've got tan A equals 3 over 1.4. So A equals tan minus 1, 3 over 1.4. When you put that into your calculator, you will get 65 degrees, or at least something close to it, but it's to the nearest degree. Now, just as the continuation of that question then, you're told that a second cable is tied to the sign at the point K, and K is halfway. So halfway, half of 3 is going to be 1.5. So that's the key thing here. And she says that the new angle is half the size of the angle. Is she correct? Well, let's find out. So draw your triangle, 1.4, 1.5. We see that it's tan again. So we've just got to put tan, we'll just call this one B. Tan B equals 1.5 over 1.4. And so we do tan minus 1, 1.5 over 1.4. And what you end up is 46.97 degrees. Now, is this half the size of the angle? Well, obviously not. 46 is not half the size of 65. So the answer is no, she is not correct. The ratios don't work like that. It's not just a linear thing like that. Okay, moving on. Let's do this one here. Question 10 then. The diagram below, not to scale, shows the plan of the university campus ABCD. Points C, D and E are main doors to the building on the campus, and these ones are pathways between the doors. Okay, not particularly relevant to any of that. You've got a diagram, you need to find some lengths. So it just says use the triangle CEB. Probably should just say about the question before that there was more parts to it, they just weren't on this. The same on this one. Because look, it's a 50-mark question, so obviously there's a lot more than just these 2 or 3 parts I'm doing, but I'm not going to go into the sine and cosine rule here now. So again, look what we're starting off with, theorem of Pythagoras. So distance from B to C. So we've got our triangle, that's this triangle here, and we've got E, B and C. We've got 9 and 41. Okay, we've done enough Pythagoras that I can just fly through this. We've got the long side, so it's 41 squared. And so it'll be minus the short side, which is 9 squared. And it actually works out as a very perfect, when you put that in, it will just be 40 metres. Okay, so that's a handy one. It's 40 metres. Okay, under that then, again, it's a show the size of the angle. That comes up quite a lot, is to show the size of the angle is 77. So it's angle CEB, so we're working with the same triangle. Okay, and we'll just leave our 41 and our 9 on it, and we'll just call the angle x. It'll save us, well, I'll call it e because that's what's in the thing. So what do we have? We have a hypotenuse and we have an adjacent. So we've got cos e equals 9 over 41, or e equals cos minus 1, 9 over 41, and that will give you, to the nearest degree, that will give you 77 degrees. So I think it's 77.3 it comes to, and comes back. Again, the reason that it tells you to show the size is this, so that if you can't do that, you can still do part 3. So hopefully you can still see it on your screens. It says to use the size of the angle to work out AD, the distance from A to D. So that's going to be important. Right, I'm just going to zoom in on this as best I can, so at least you can see something. So we worked out that this was 77 degrees. So in a whole straight line, you're going to have 180. So let's do 180 minus 77 minus 37, because we're going to need this angle to work out AD, because we're looking for this here. So we need this angle here. So 180 minus 77 minus 37 is going to leave us with 66 degrees. So that's an important thing to use, is that this is 66 degrees. And now that we've got that, we've got our triangle. Let's draw another one. And it's 66 here and 80 here. And we want our opposite. Okay, so we've got an opposite and a hypotenuse. So what do we do when we have an opposite hypotenuse? You should know this by now. So sine 66 equals, we'll just call it O over 80. So to get rid of this on the bottom, we'll times it by 80. So we'll get 80 sine 66. It'll give you 73.08 is, AD here. So it says to the nearest meter, so it's approximately 73 meters. All right, so again, we're just using our ratios, sine, cosine, or tangent. Remember them all, SOH, CAH, TOA. And that's how we'll always remember them, opposite, hypotenuse, and adjacent. Okay, and just to finish off now for this video, if anyone needs to pause it there, they can do that to take it down. And now let's just move on to the last one, a few more challenging ones for anyone that's trying to push on to do some of these. So here's just a couple of examples from the Leave Insert higher level papers over the last while. So there's a lot going on here. Windscreen wipers, and it's got a width 180, so we've got a 180 there, and a height 100, that's there. And M is the midpoint, so that's actually important. I would suggest you pause it and try and read it yourself first. But M is the midpoint of PQ and N is the midpoint of SOR. So that means that each side is the same. That's important. Okay, and O is an element of NM. Okay, so they both are, yeah, it's on the line NM, so it's just straight in line with it. So there's a wiper blade that rotates this way, so it's rotating like that. And it cleans, and you're told it's a sector. So a sector is part of a circle. Okay, and so the wiper cleans this much, the slightly shaded part. And they all lie on this rectangle. Okay, and the line segment ORQ, where's ORQ? It's extended 20 meters to S. Yeah, and it's a right angle, so OTR is a right angle. So there's like a million things going on there in this question. That's a lot of writing, but let's just work with what we've got. We're first told to show that OB equals 120 centimeters. So let's just first look at this. So we've got 20. So you're told to show that OB is 120. The thing is, on a circle, these are sectors, so remember they're part of a circle. So these are all going to be the same distance. So if you have 20 here, up as far as M, you have 20. So you can see that up to here, it's 20. And up to here, it's 100. Okay, when the wiper sort of flips itself around that way, it's also going to be 120 when it goes around to the right. So it's just going to be, so OB is equal to OM plus MN. So it's literally just 20 plus 100. So it's 120. So fairly straightforward, just to notice that because these are both, they're both radiuses or radii, So that's the radius here, and that's another radius there. Okay, so hence, so that means using that, show that BOT is 41.4 degrees. Right, so we're looking at BOT. So that means we're looking at this triangle up here. So let's draw our triangle so that we're not getting distracted by the 70 other things on them. So we've got BOT, and the angle is that. So we know that the width of this, the halfway width, so you see here, it's going to be the halfway, you're going to have a 90 here. So we'll have a 90 on the bottom here, and the length is 120. Okay, so it's literally just a straightforward SOHCAHTOA question. So we've got an adjacent and we've got a hypotenuse. So we've got cos, we'll just say cos O equals 90 over 120. So O equals cos minus 1, 90 over 120. And that will give you, correct to one decimal place, 41.4 degrees. So although it's a complicated diagram, the maths is actually very simple there. You just need to find that. Okay, so if you're done that, I'm going to zoom into the next bit. So hence, work out the area of B line, A line. So remember this here is 41.4. And remember they're the same, so that means that this here is also 41.4. And if you remember that in a straight line there's 180 degrees, so we're going to minus two 41.4s off that to find our middle angle. That's important for this. So that leaves you with 97.2 degrees. Okay, my writing really won't work out there, but that is going to be a 97.2 degrees in there. Okay, so if you remember, the area of a circle is pi r squared. Okay, that's the area of the circle. And you need to work out the area of this whole big thing. So essentially, you want the area of the big bit, or well, the area of the whole bit minus the area of the little bit. And that will give you the shaded area there. So we know that each part is 97.2 degrees out of a total of 360 degrees because it's a circle. Okay, so 97.2 over 360 times pi times the radius squared. And we know the radius of the big bit is 120 squared. So that's just going to give you 3888 pi when you put that in the calculator, and we'll round to the centimetre at the end. Okay, but then you also, that's the big bit, but you need to have the small bit. So we need to do the same thing, 97.2 over 360 pi, and then the small radius squared is just 20. 20 squared. That's not exactly right. So 1 second. Sorry, the radius is not 20. That's just my mistake there. Still going to be using the same thing, but you see in here it was so 20 across and 20 up, and this here is the radius. So you just need to do a little Pythagoras there. The easy thing to miss is the square root of 20 squared plus 20 squared. That will give you 20 root 2. So pi 97.2 over 360 pi 20 root 2 squared. Okay, so that will give you 216 pi for the area there. Obviously these are centimeters squared, both of them. Okay, so you've got the big bit and you've got the small bit. Simply minus them from each other. So 3888 pi minus that will give you, that's 3672 pi. And just SD it on your calculator. You will end up in centimeters squared with sorry about that. What has happened there? 11535.9, but it says the nearest centimeter squared, so we're grand. 0.928, and that will give you an approximate 11536 centimeters squared. Okay, so just be careful there. I nearly missed that bit, that it was the radius is 20 root 2 of the small bit, not 20. Okay, so you can stop and digest that. I've got one more bit of a question. I think I've been going for a long time, a lot longer than intended here, but we'll just keep it going. Final question. Let's do this one. It's a fairly straightforward one. Okay, so Hulk is a cyclist. The diagram shows a road AB, which is not to scale. AC is horizontal and BC is vertical. So we've got 9 and a 70. The gradient is BC, so that's that bit, over AC, over that bit, as a percentage. See the gradient of AB, but you need to find AC. So this is just a Pythagoras. Okay, here's a long side, here's a short side. So let's just quickly Pythagoras this. We've got 70 squared minus 9 squared, which will give you 69.42. So B will be 69.42 meters. And the gradient is BC over AC, so we'll do 9 over 69.42, and it's as a percentage, so we times it by 100. So you get 12.96, or approximately 13%. So it's a 13% rise of the road that Olga is going up. Okay, moving on from that then, that was Pythagoras. Again, even though it's higher level, we're still just doing Pythagoras. And now we've got this bit here. So Olga wants to measure the vertical height of a hill. Point H is at the top of the hill. R and P are 20 meters apart, horizontal at the bottom of the hill. So she wants the angle of elevation. She has it 17. Taking O to be the point directly below H, horizontal with R and P. Olga also measures the angles OPR and QORP. All of these are shown in the diagram. So let's just look at the diagram. We want the distance OH. So this is what's important to get. Okay, so there's a few things we're going to need on this. So we've got a triangle with two angles. So let's find our missing angle here first. So we'll do 180 minus 88 minus 87. And that leaves that angle as 5 degrees. So it's obviously not to scale because it looks a lot bigger than 5 degrees. Okay, now, just to get, so we want this height, so that means we first need this bit here. So we do actually just need the sine rule here. So we will do 20 over sine 5. So if you don't know the sine rule, don't worry, it's fine, is equal to 80, sorry, is equal to OR over sine 87. Okay, so essentially the sine rule says that A over sine A equals B over sine B. So when you're working with opposite sides, you can do that. Okay, but just multiplication anyway, you just multiply both sides by sine 87. So you multiply this by sine 87. Both sides multiply by that, and you get OR equals 229.16 is OR. Okay, so we get 229.16 down here, and that leaves us with a nice triangle, just like this. So we've got 229.16, we've got 17, and we've got OH. Now, we know how to get the height here. So we've got an opposite, we've got an adjacent. You know what to do at this stage. We have tan 17 equals OH over 229.16. So that's on the bottom. We multiply that by 229.16, and we'll put a 229.16 over here. And that will finish it off at 70.06 equals OH, and the thing says to the nearest meter. So 70 meters is the height of that. Okay, so there was quite a lot in that. The higher level one obviously had more bits and pieces to do, but in the end it was still, if I just zoom out a little here, if that works. Oh, that's a bit too small. Again, what are we working out as? It's just Pythagoras over here and SOHCAHTOA over here. And obviously there's more, there's some cosine rule and stuff after that. But all of that will do for this one. Okay, so again, over half an hour, but that's a lot of sine, cosine and tangent. Okay.